This is SpaceTime Series 21, Episode 54. Coming up on SpaceTime, the cataclysmic collision that's helped shape Uranus. Listening in on an interstellar visitor, just to confirm it's not an alien spacecraft. And the monster Eta Carinae shooting out cosmic rays. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study claims Uranus was hit by a massive object about twice the size of the Earth, causing the entire planet to tip over on its side. The findings, reported in the Astrophysical Journal, could explain the ice giant's freezing temperatures. Astronomers carried out the research using high-resolution computer simulations of different types of massive collisions with Uranus in order to try and work out how the planet evolved. The research confirms previous studies showing that Uranus's tilted position was caused by a collision with a massive object, most likely a young protoplanet made of rock and ice, during the formation of the solar system some 4.5 billion years ago. The simulations also suggest that debris from the impactor could have formed a thin shell near the edge of the planet's ice layer, trapping heat emanating from Uranus's core. The trapping of this internal heat could in part at least help explain the extremely cold minus 216 degrees Celsius temperatures of the planet's outer atmosphere. The study's lead author, Jacob Kagiris from Durham University, says Uranus spins on its side, with its axis pointing almost at right angles to those of other planets in the solar system. He says while this was almost certainly caused by a giant impact, little is known about how it actually happened and how else such a violent event may have affected the planet. To try and work out what happened, the authors ran more than 50 different impact scenarios using a high-powered supercomputer in order to see if they could recreate the conditions which shaped the planet's evolution. Their findings confirm that the most likely outcome was that the young Uranus was involved in some sort of cataclysmic collision with an object maybe twice the mass of Earth, if not larger, knocking the ice giant over on its side and setting in process the events which helped create the planet we see today. There's been a long-standing question mark about how Uranus managed to retain its atmosphere when a violent collision may well be expected to have sent that atmosphere hurtling into space. According to the simulations, this can most likely be explained by the impacting object striking a grazing blow on the planet. So the collision was strong enough to affect Uranus's tilt, but the planet was able to retain the majority of its atmosphere. The research could also help explain the formation of Uranus's rings and moons, with the simulation suggesting that the impact would most likely have jettisoned heaps of rocks and ice into orbit around the planet. All that rock and ice would have eventually clumped together to form the planet's inner moons, and perhaps also alter the rotation of any pre-existing moons already orbiting Uranus. The simulations also show that the impact could have created molten ice and lopsided lumps of rock inside the planet. And that could help explain Uranus's tilted and off-center magnetic field. Understanding Uranus is important because it's similar to the most common type of exoplanets, planets found outside our solar system. And the researchers hope their findings may also help explain how these planets evolved, helping them understand more about their chemical composition. The current best idea to explain the formation of the outer solar system involves the grand tack hypothesis of planetary migration. In this, Jupiter was the first of the planets to form, coming together soon after the Sun formed. It initially migrated inwards from its point of origin, almost as far as the present-day orbit of Mars. Saturn, forming right behind Jupiter, also began migrating inwards in its shadow. Eventually, an orbital resonance between Jupiter and Saturn caused both planets to begin migrating outwards again to their present-day orbits. As they did, their gravitational perturbations and resonances caused a major upheaval in the outer solar system, with the ice giants Neptune and Uranus being pushed further outwards and swapping their orbital positions. Some calculations show that a possible third ice giant was also there. It was either flung out of the solar system altogether and is now floating through interstellar space as a rogue planet, or it now resides near the outer edge of the solar system, possibly as the long-sought-after Planet 9. You're listening to Space Time. I'm Stuart Gary. When the interstellar visitor Mao Mao was observed, failing to slow down as much as it should due to the gravitational pull from the Sun, scientists began exploring several possible scenarios to try and explain what was happening. They checked to see if the observations could be explained by solar radiation pressure, by friction-like events, or by the Yarkovsky effect caused by heat radiating away from the surface after first being warmed up by the Sun. Astronomers also tried to determine if the gain in speed could have been caused by an impulse event, such as a collision, by Oumuamua being a binary object, or by it being a highly magnetized object. Now, as we reported last week, scientists eventually concluded that the 230 by 35 metre dark red-coloured tumbling space rock was simply outgassing material following its earlier close encounter with the Sun. It seems Oumuamua may be an interstellar comet rather than an asteroid. One of the more unlikely ideas they examined was the possibility that Oumuamua was in fact an interstellar spaceship. Now, this was also rejected, firstly because the smooth and continuous change in speed isn't typical for thrusters, secondly because the object's tumbling through all three axes, and finally because it's not emitting any artificial electromagnetic energy, such as radio chatter or navigational signals. The idea of Oumuamua being a spaceship was based purely on its shape. Its silhouette is very much like a long, elongated cigar. And the rest was an invention of the tabloid media. One of the groups of astronomers which ended up checking out the asteroid fairly closely were those from the Murchison Wide Field Array telescope in outback Western Australia. They checked for radio transmissions coming from the object at frequencies of 72 to 102 MHz, similar to the frequency range at which FM radio broadcasts. While, as expected, they didn't find any signs of intelligent life, the research did help expand the search for extraterrestrial intelligence SETI from distant stars to objects much closer to home. When Mao Mao was first discovered back in October 2017 by the Pan-STARRS telescope in Hawaii, astronomers thought it was a comet or asteroid from within the solar system. But after studying its orbit, measuring its speed, and observing its long cylindrical shape, they realized Mao Mao was neither and had in fact come from interstellar space. Telescopes around the world trained their gaze on this mysterious visitor in an effort to learn as much as possible before it headed back out of the solar system again, in the process becoming too faint to observe in detail. Professor Stephen Tingay from the Curtin University node of the International Centre for Radio Astronomy Research says the Murchison Wide Field Array team didn't intentionally set out to study Oumuamua. However, because the array observed such a large fraction of the sky at once, scientists simply had to go back through their data and analyse it after the fact. Tingay speculates that if advanced civilizations exist elsewhere in the galaxy, they may well develop the capability to launch spacecraft over interstellar distances, and that these spacecraft may well use radio waves to communicate. Tingay says while the possibility of Oumuamua being an alien spacecraft was always extremely low, maybe even zero, as scientists, it's important to avoid complacency and examine observations and evidence without bias. The Murchison Wide Field Array is located in a very remote region of Western Australia. It's also one of the most radio-quiet regions on the planet, far from human activity and radio interference caused by technology. The facility consists of thousands of antennas attached to hundreds of tiles that dot the ancient red landscape, relentlessly observing the heavens day after day, night after night. Tingay and colleagues look back through all the telescope's observations from November, December and early January, at a time when Oumuamua was between 95 million and 590 million kilometres from Earth. They found nothing, but as the first object from interstellar space to be discovered in our solar system, Oumuamua gave them an interesting opportunity to expand the search for extraterrestrial intelligence from traditional targets such as stars and galaxies to objects that are much closer to Earth. The name Oumuamua is Hawaiian. It means the messenger that reaches out from the distant past. Combining observations from a host of telescopes has allowed scientists to determine that Oumuamua is most likely a cometary fragment. It's lost most of its surface water after being bombarded by cosmic rays through its long journey through interstellar space. Researchers have now suggested that there could be more than 46 million similar interstellar objects crossing through our solar system every year. While most of these objects will be too far away to study with current technologies, future telescopes such as the Square Kilometre Array, now being built across Australia and South Africa, will allow scientists to understand more about these interstellar interlopers. Tingay says once the SK is online, astronomers will be able to look at large numbers of these objects and partially at least balance out the low probability of a positive detection.
Well, once the object was detected from the observatory in Hawaii and its trajectory had been calculated, it was pretty quickly realised that it was not an object that originated from our solar system and was the first object to be discovered that came from somewhere else and was merely traversing our solar system. So once we understood that, we were able to look through the data archives for the NWA, and we realised that at one point during the object traversing the solar system, it actually flew through our field of view coincidentally. And so we were able to extract those data from the archive, process the data, and look for any transmitted signals from the object.
Transmitted signals, I take it you weren't really expecting to find any, but I guess you wanted to make sure just in case.
Well, by that stage, it was understood that the object had two very interesting characteristics. One, that it came from outside our solar system, and as I say, it was the first time we'd seen anything like that. And two, it had a very suspicious geometry. So it was about 200 metres long, about 35 metres wide. That's almost exactly the same dimensions as the spacecraft in 2001, the Space Odyssey.
Is that right?
And so speculation was pretty quick that, there is some infinitesimally small possibility that it could be a spacecraft. So we processed our data with no expectations of finding anything. But at the end of the day, as a scientist, you have to look and process your data without prejudice. So even if there is a tiny chance that you might find something groundbreaking, you must have a look at the data before you exclude it. So that's what we did.
Of course, you just mentioned the shape of this object. It's often described as a cigar-like shape, and often when you hear reports of UFOs, that's the same term a lot of people who see these things claim they see, a cigar-shaped mothership.
Yeah, so I mean, this is how it's portrayed in our popular culture, and there are some good physical reasons for why an interstellar spacecraft might have that type of geometry, but obviously very, very unlikely. Having said that, I'm not sure I've seen a really convincing explanation of why the object should have that particular geometry. Most objects of that size would, over time, become spherical, like most of the objects in our solar system. So there is a bit of a mystery still behind that, just as to why it has that geometry. And there's several theories, but the object has now exited our solar system, so I guess we'll never really know.
What are the theories behind this unusual shape?
I think the one that I've seen that's probably most plausible is that rather than being cigar-shaped, it's actually composed of two objects that have sort of almost coalesced but not quite, and they're sort of in orbit around each other and connected via some sort of material bridge, and so they've maintained that geometry as it's progressed in its journey. It's not my particular deep area of expertise, but that sort of seems like the most plausible option.
Well, that almost describes what we've seen with Comet 67P, the famous duck-shaped comet that the Rosetta spacecraft visited. It was composed of two objects which have melded together over time.
Yeah, that's right. So I guess there are sort of local examples of this. It's probably had to maintain that geometry over many, many millions of years as it's journeyed from wherever it originated from to get to us. So it's a long time for it to maintain that geometry, but it's not my area of deep expertise, so I'd probably defer to others on that matter.
It's also an incredible journey to undertake. It would also have had to have built up a lot of speed just to get out of its own star system.
Yeah, so clearly we don't know where it originated from and how it was ejected from presumably its origin solar system, but it would have had to reach escape velocity probably through interaction with other bodies, and then for it to continue its journey over an extremely long period of time, presumably to reach us. So yeah, when you think about it, it's an amazing journey that it took.
Any ideas as to what might have happened? Is this the result of a collision, a violent collision, or maybe some gravitational perturbations involving other objects?
Yeah, I'm guessing some sort of gravitational perturbation through the interaction of objects in a solar system or proto-solar system, or the passage of a star nearby by a solar system or something like this has resulted in the ejection of this and probably many other objects from that solar system and sort of had them disperse on different trajectories.
It raises some interesting issues too, doesn't it? I mean, when you look at the outer reaches of our own solar system, you have the Kuiper belt where most of these where these trans-Neptunian objects can be found. Beyond that, there is a more extended field called the Oort cloud or the Oort cloud, and that's really interesting because the Oort cloud is sort of this very sparsely populated sphere of icy debris and bodies, some of which are within our solar system, but others are sort of tagging along beyond our solar system, but still under the influence of the sun's gravity.
Yep, all true. And I guess over time, some of those objects are expelled from our solar system and make a journey to other places in the galaxy. Presumably this sort of thing is happening all the time. And I did see a calculation that concluded that this type of thing should not be unexpected. And I think they calculated that you would expect one of these types of objects to be present at any given time somewhere between the Earth and the Sun. So they should be quite common was the conclusion. I guess the thing is that they're tiny objects in a large space and you have to work quite hard to detect them. And I guess they detected this one from the observatory in Hawaii by chance. Presumably there's always something like that in our solar system. We just don't necessarily see it.
And even with this one, it was already on its way out when it was first detected.
Yeah, late last year it passed relatively close to the Sun and the Earth. I think it was within sort of 100 million kilometres or something. So that's, yes, but by the time you've detected it, tracked it, measured its orbit and determined that it was on its way out, you've got a limited amount of time to study it, unfortunately.
How do we know that it came from outside our solar system? I guess there are two things we've got to look at, aren't there?
Well, it had a speed and a trajectory through our solar system that indicated that it was not bound to the Sun. So it was basically beyond the escape velocity for our solar system.
That's Professor Stephen Tingay from Curtin University. And you're listening to Space Time. I'm Stuart Gary. A new study has found that Eta Carinae, the most luminous and massive stellar system within 10,000 light-years of Earth, is accelerating particles to high energies, some of which could be hitting our planet as cosmic rays. The findings, reported in the journal Nature Astronomy, are providing new insights into this giant, destined to explode any time now as a powerful core collapse supernova and possibly even a gamma-ray burst, one of the most powerful explosions since the Big Bang of creation. Cosmic rays are subatomic particles, electrons, protons and atomic nuclei, often accelerated at close to the speed of light. Scientists know they're produced in stars, both during their lifetimes and when they die in supernovae. The study's lead author, Kenji Hamaguchi from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says astronomers know that cosmic rays can be produced in really extreme environments, and this new analysis confirms that Eta Carinae is one of them. Cosmic rays with energies greater than 1 billion electron volts reach the Earth from well beyond the solar system. But because these particles all carry an electrical charge, they don't travel in straight lines, instead changing course whenever they're deflected by a magnetic field. And because of this, astronomers can't determine their points of origin. Eta Carinae is located some 7,500 light-years away in the southern skies constellation of Carina, the Keel. It's famous for a 19th century outburst that briefly made it the second brightest star in the sky. This event also created a massive hourglass-shaped nebula called a homunculus, but the actual cause of the eruption remains poorly understood. We know the system contains a pair of massive stars. Both stars are on eccentric orbits, bringing them close together every 5.5 years. The stars contain around 90 and 30 times the Sun's mass respectively, and they pass within 225 million kilometres of each other during their closest approach. Now, to put that in perspective, that's about the average distance between the Sun and Mars. Both of Eta Carinae stars drive powerful outflows called stellar winds, and the location where these winds collide changes during the orbital cycle, producing a periodic signal in low-energy X-rays, which NASA's been tracking now for more than 2 decades. NASA's Fermi Gamma Ray Space Telescope has detected a change in gamma rays. These are the highest forms of energy, far more powerful than X-rays. And according to the Fermi data, that source is in the direction of Eta Carinae. The trouble is, Fermi's vision isn't as sharp as that of X-ray telescopes, so astronomers couldn't confirm the connection. To try and bridge the gap between Fermi's observations and higher resolution low-energy X-ray monitoring, Hamaguchi and colleagues turned to NuSTAR. Launched in 2012, NuSTAR can focus X-rays of much greater energy than any previous telescope. Using a combination of both newly taken and archival data, the team examined NuSTAR's observations acquired between March 2014 and June 2016, along with lower-energy X-ray observations from the European Space Agency's XMM Newton satellite over the same period. We already know that Eta Carinae's low-energy or soft X-rays come from gas at the interface of the colliding stellar winds, a region where temperatures can exceed 40 million degrees Celsius. The thing is, NuSTAR detected a source emitting X-rays above 30,000 electron volts. That's some 3 times higher than what can be explained through shock waves from colliding winds. Now, by comparison, the energy of visible light ranges from about 2 to 3 electron volts. The author's analysis shows that these hard X-rays vary with the binary's orbital period and show a similar pattern of energy output to the gamma rays observed by Fermi. Hamaguchi says the best explanation for both the hard X-rays and the gamma-ray emissions are electrons accelerated in violent shock waves along the boundary of the colliding stellar winds. So the X-rays detected by NuSTAR and the gamma-rays detected by Fermi arise from starlight, given a huge energy boost by the interactions of these electrons. Some of the superfast electrons, as well as other accelerated particles, then escape the system. And perhaps eventually some reach the Earth, where they're being detected as cosmic rays. NuSTAR's principal investigator, Fiona Harrison from Caltech in Pasadena, California, says science has known for some time that the region around Eta Carinae is a source for high-energy emissions in both X-rays and gamma rays. But the origin remained mysterious until NuSTAR was able to pinpoint the radiation, show it comes from the binary, and study its properties in detail. You're listening to Space Time. I'm Stuart Gary. A new study claims the near-Earth asteroid Phaeton may be reflecting less light than previously thought. The revelation's important because astronomers use the amount of light reflected off distant asteroids to help determine their size and, consequently, whether they pose a danger to Earth. Phaeton's classified as a potentially hazardous asteroid, although no potential issues are expected in at least the next 400 years. The way an object reflects light depends not only on its albedo, that is, the percentage of light it reflects, but also on the illumination angle. Astronomers are interested in learning how the polarization changes when sunlight's reflected off the surface of an asteroid. Scientifically, light is referred to as an electromagnetic wave. The waves create changes in the electric and magnetic fields. The direction of these changes can either be random or they can be aligned. Now, when the electromagnetic effects of light are aligned, the light is said to be polarized. Astronomers using Japan's 1.6-meter Perkit telescope observed Phaeton, studying the changes in the polarization of the light it's reflecting at different illumination angles. The results show that at some angles, the light being reflected from Phaeton is the most polarized light ever observed among small bodies in the solar system. It's also surprisingly blue in color. The fact that its reflected light is so strongly polarized is one of the mysteries surrounding this curious asteroid. One possible explanation for the strong polarization is that the surface of Phaeton may be darker than expected. Asteroid surfaces are covered with heaps of loose rubble called regolith. Now, usually, when light reflected from a rough surface strikes another part of that rough surface and is reflected again before being reflected towards the observer, these multiple scatterings tend to randomize the polarization. If the albedo is lower than previously thought, that would reduce the effectiveness of the multiple scatterings. So that polarized light, which has only been reflected a single time, would dominate. Other possibilities that could reduce the effectiveness of multiple scatterings are that the rubble covering Phaeton's surface may be composed of larger grains, or that the material is more porous than expected. A possible mechanism that produces larger grains is sintering, and that's interesting when it comes to Phaeton, because Phaeton's surface gets heated to over 1,000 degrees Celsius during its close approach to the Sun. And such extreme heating would cause sintering on an asteroid surface, resulting in coarser grains. First discovered back in 1983 in images taken by NASA's infrared astronomical satellite IRIS, 3200 Phaeton's unusual in that it leaves a strong debris trail which produces the annual Geminids meteor shower in mid-December. Also, the 5.8 kilometre wide space rock's high orbital eccentricity more closely resembles that of a comet than an asteroid. And in fact, it may well have become an asteroid that simply run out of the volatile gases that usually characterise a comet. Phaeton's orbit crosses the inner terrestrial planets Mercury, Venus, Earth and Mars. On December the 16th last year, Phaeton came within 10,312,000 kilometres of Earth, its closest approach in 40 years. But a much closer approach is slated for December the 14th, 2093, when it will pass just 2,960,000 kilometres from Earth. And that's the reason it's classified as potentially hazardous. Phaeton's named after the son of the Greek sun god Helios. Legend claims Phaeton almost destroyed the Earth by stealing Helios' chariot and scorching the Earth with the sun, almost causing an apocalypse. And that's all very appropriate. After all, Phaeton approaches the sun closer than any other named asteroid, with a perihelion of less than 21 million kilometres, less than half of Mercury's perihelion distance. It's coming so close to the sun which causes its surface temperature to heat up to these extreme 1,000-degree levels. Observations by NASA's STEREO spacecraft observed dust tails radiating off the surface. And in 2010, Phaethon was detected ejecting dust. Scientists think the intense heat generated by its close approaches to the sun causes fractures in the gravel and rocks on the asteroid's surface, similar to mud cracks in a dry lake bed on Earth. Phaeton's composition also fits with the notion of a cometary origin. It's classified as a B-type asteroid because it's composed of dark material. And B-type asteroids are thought to be primitive volatile rich remnants of the early solar system. Its composition, orbit and dust trail have led astronomers to refer to Phaethon as a rock comet. The Geminids meteors which it produces have a yellowish hue to them, and they tend to be a bit larger and more solid than typical meteors from comets. They also move more slowly, travelling at a leisurely 35 kilometres per second, compared to some cometary meteor showers travelling at speeds of around 72 kilometres per second. Japan's interested in studying Phaethon because the Japanese Aerospace Exploration Agency JAXA is planning to launch its Destiny Plus probe in 2022. Destiny's mission will be to study Phaethon, as well as the various minor bodies originating from the rock comet, in order to help astronomers better characterise its surface geology. You're listening to Space Time. I'm Stuart Gary. Well, it sounds like the plot from the hit television comedy series Big Bang Theory, but NASA has called on Russian spacecraft manufacturer Inertia to fix and maintain its International Space Station waste and hygiene compartment. That's NASA speak for space toilet. The United States purchased the Russian-made Dunny, that's Australian speak for toilet, back in 2007 for $19 million after American designs failed to be the flushing success everyone had hoped for. It seems there have been occasions when things haven't gone quite as smoothly as one would like during moments of contemplation, transforming the zero-gravity waste disposal system into more of a waste distribution system, which is every bit as bad as it sounds for two reasons, number ones and number twos. So now, before anything unpleasant hits the fan, NASA's renewed its contract with Inertia to keep things flowing smoothly. Space toilets are nothing new. They've been a standard fixture aboard Russian Soyuz capsules and the Mir space station, as well as the American Skylab and the space shuttles. The space station has two toilets, one fitted aboard the American Destiny module, the other fitted aboard the Russian Zvezda module. But the space station's toilets have raised more than a whiff of controversy over the years, especially when Washington refused to allow the Russians to use their toilet. That happened after Russia started billing NASA to take their astronauts to the orbiting outpost. Truly a case of where no Russian has gone before. And yes, when I wrote this script, I did think about wiping some of those puns. You're listening to Space Time. I'm Stuart Gary. And time now to take a look at some of the other stories making news in science this week with the Science Report. A new study claims there's no clear evidence that taking cannabis works for pain relief. Researchers from the University of New South Wales looked at how the use of cannabis helped ease the pain of 1,500 patients, the extent to which pain interfered with their everyday lives, and their use of prescription opioids. The participants had been in pain for an average of 10 years and had taken prescribed opioids for their pain for an average of 4 years. Researchers found that compared to those not using cannabis, participants who were using the drug had greater pain and anxiety, were coping less well with their pain, and reported that the pain was interfering more with their lives. The findings reported in the Lancet Medical Journal recommended caution, claiming there was no clear evidence that cannabis reduced pain severity or pain interference or led participants to reduce their use of opioids. A new study warns that tropical cyclones and hurricanes are slowing down, not in wind speed, but in the time they take to cross a set distance. In other words, they're taking longer to travel across the planet. The findings, reported in the journal Nature, claim that over the past 70 years, hurricanes have slowed by about 10% globally, with some land areas such as Australia experiencing an even slacker pace, 19% slower. The problem is, the more time tropical cyclones spend over land, the more devastation they can wreak, from rainfall, from wind-induced damage, and from tidal surge. The authors say the slowdown is likely to contribute to worsening destruction, alongside the associated increase in rain rates caused by global warming. Well, it looks like Samsung have adopted a larger is better policy, with the new Galaxy Note 9, due for release on August the 9th, expected to have a bigger 6.38-inch display compared to the current 6.32-incher. There's also growing speculation the new phone could be the first from Samsung to include an in-screen fingerprint scanner. However, there are other reports claiming it won't be ready in time. Meanwhile, BlackBerry's new Key 2 smartphone is also expected to go on sale in August. The new device will include the new Android 8.1 Oreo, or is that Oreo, operating system, and a 12-megapixel dual rear camera. We already know that whales and dolphins are capable of intricate social behaviours. But can they grieve? Well, a new study of 78 records of these mammals interacting with their dead suggests that some whales and dolphins do appear to have trouble letting go. Dolphins are the most likely to display a tentative behaviour towards their dead. Most interactions recorded were of adult females with a dead calf or juvenile, often trying to carry it or care for it. The findings are reported in the journal Zoology. Well, it's something we've all suspected, but a new study has confirmed that well-educated people really are more likely to wear glasses. Using data from over 65,000 people in the UK, researchers analysed genetic variants associated with myopia or short-sightedness, and then compared them to genetic variants associated with years of schooling. The findings, reported in the British Medical Journal, found that spending more time studying really is associated with a greater risk of developing myopia. And finally for now, well, it sounds like something straight out of the future, and, well, I guess it is. Imagine going to the movies and then controlling how the story gets told. A new Braincontrolled film called The Moment has just been launched, and it works by picking up the reactions of viewers from an EEG headset and then switches the storyline depending on their response. With the details, Alex Zaharov-Reutt from IT Wire.
The latest trend in movies is a movie you control with your mind. This is called The Moment, and it's launched at the Sheffield Documentary Film Festival, and you're able to put a headset on called the Neurosky. It's the Mind Moment 2. It's the second version of this headset, and it's normally used for apps and controlling various things in apps, but the sensor reads your brainwaves, and then it produces an action, and this movie takes that action and then can change the scene, can change the music, can change the tone, and to create
Do you have
something
to think
different.
in Russian like on the Firefox movie?
Well, you can think of whatever language you like, but the director's name is Richard Ramchon. He's doing a PhD computer science, and to create this 27-minute film, he had to create 3 times the material he created normally and about 6 times the amount of sound. So each scene's got a possible 6 combinations, and over 18 scenes, there are over 101 trillion possible combinations for each viewing.
Well, that's
so
because
that
everyone's going to come up with their own ideas based on what they're seeing. And so everyone's going to get a unique movie, but it's going to result in a lot of discussion and at dinner after the movie.
Look, you can't all see a different movie at the moment. One person puts the controller on, and other people watching are seeing what that person does. They did experiment with having 3 headsets, and then you can either take the average of what people are thinking, or you can change the... One person is in control of the music, one's in control of the scenes, and one is in control of the blending. So you can have
right, so you haven't got a theatre full of people wearing these headsets and then you have 2,000 different versions of the movie playing at once.
That's right. It's very primitive technology, but the fact you can do it at all is amazing. And you actually do have TVs out there where one person can sit on one side of the couch and see one screen like a movie, and the other person can sit on the other side and be playing a game. That's not very common, but those TVs exist. So in theory, you could possibly do that. But look, braincontrolledmovie.co.uk, braincontrolled with a double L-E-D at the end, movie.co.uk. And there's a great article written in the MIT Technology Review about the movie, which I recommend you read.
And that report by Alex Zaharov-Reutt from IT Wire. You're listening to Space Time. I'm Stuart Gary, and that's the show for now. You can subscribe and download Space Time as a free twice-weekly podcast through Apple Podcast iTunes, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from spacetimewithstuartgary.com, or from your favourite podcast download provider. Spacetime's also broadcast coast to coast across the United States on Science 360 Radio by the National Science Foundation in Washington, D.C., and available around the world on TuneIn Radio. If you want more Spacetime, check out our blog where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us on Twitter through @StuartGary, at Spacetime with Stuart Gary on Instagram, and on Facebook, just go to www.facebook.com/Spacetime with Stuart Gary. Spacetime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to Spacetime with Stuart Gary. This has been another quality podcast production from Bytes.com.